Okay, Wildcats. Today we're looking at 5.2 fitting quadratic functions to data assignment tutorial. Question number 1. Find an approximate quadratic function model for the graph data by estimating the coordinates of the vertex and using one other point. Part 1. Choose the best estimate for the vertex coordinates. Okay, that point is 4, 8.5 right here. There's your vertex. Okay. Part 2 of 2. All right, use the vertex estimate 4, 8.5 from part 1 and the point 84 to find a quadratic function model round A, and I'm going to use capital A, to the nearest 10. Step 1, solve for A using y equals A parentheses x minus h squared plus k. All right, well, if this is the vertex, this is h and this is k, and the point is x, y. Okay, so we're going to plug those points in. So y is 4 equals A parentheses x, which is 8, minus h, which is 4, squared, plus 8.5. Okay? Now, 8 minus 4 is 4, so that's 4 equals A, parentheses 4 squared, plus 8.5. Well, 4 squared is 16, so that's 4 equals 16A, plus 8.5. We're going to subtract 8.5 from both sides. So 4 minus 8.5 is minus 4.5, which equals 16a. Divide both sides by 16. We're going to plug that into our calculator, okay? So let's go to Google, Desmos.com. So we want scientific calculator. Negative 4.5 divided by 16 is negative 2.8. They want it to the 10th place, so that's going to be negative 0.3. Okay, so there's your A value. And the approximate model in the vertex form is f of x equals negative 0.3 x minus 4 squared plus 8.5. All right, let's go ahead and move on to question number 2. Okay, find an approximate quadratic function model for the graph data by estimating the coordinates of the vertex and using one other point. Part 1, choose the best estimate for the vertex. So the best estimate for the vertex is right here. This is your vertex, 4, 0.75. Okay? All right? Part 2 of 2. Use the vertex estimate 4, 0.75 from part 1 and the point 8, 4 to find the quadratic function model round to A, and I'm going to use capital A, to the nearest hundreds. Okay? First off, this is H, this is K, and this is X, this is Y. Okay? Now we're going to substitute those values in, so then that's 4 equals A times X, which is 8, minus H, which is 4 squared, plus K, which is 0.75. Okay? Now, we already know that 8 minus 4 squared is 16, but we can use the scientific calculator to do that if we want. Parentheses 8 minus 4 squared is 16. So then that's 4 equals 16a plus 0.75. We're going to subtract 0.75 from both sides. So 4 minus 0.75 is 3.25 equals 16a. Divide both sides by 16. So this is where we can use Desmos calculator again. So 3.25 divided by 16 is 0 point, and they went to the hundredths place, so 0.0. So A equals 0.20. Okay? So an approximate model in the vertex form is f of x equals 0.20 x minus 4 squared plus 0.75. All right, let's move on to question 3. All right, question 3. Choose the best estimate for the intercepts. Okay, now when they say intercepts, we're talking about the x-intercepts. Okay? Now you want to find the x-axis, which that's where y is 0. That's here. Okay, so this is the x-axis. That's where you're going to find your x-intercepts. Now follow the points. You're there, and you're there. So our x-intercepts are 1.7 and 9.2. Okay? Use the intercept estimates 1.7 and 9.2 from part 1 and the points 5, 9 to find a quadratic function model. Round your answer to for A, and we're going to use a capital A, to the nearest hundreds. Okay? Step 1. Find the approximate quadratic function model using the x-intercepts x1 equals 1.7 and x2 equals 9.2. The function y equals a parentheses x minus x1 parentheses x minus x2 and the point 0.59. Okay? This is x. This is y. Okay? We have x1, we have x2. So now let's plug the values in here. Okay? So that is our y value, which is 9, equals a, we don't know, x, which is 5 minus 1.7, and 5 minus 9.2. Okay? All right, go ahead and write that down. All right, let's move on to step 2. Now, step 2, we're going to use that to solve for A. Now, we can find this number right here just using Desmos calculator. So we can put that all in at once. So let's do that. So 5 minus 1.7 parentheses 5 minus 9.2. That's negative 13.86. Okay. So this is negative 13.86. So now we're going to divide negative 13.86 by both sides. Okay. This divides becomes 1. Now we can use Desmos calculator to get that number. 9 divided by negative 13.86. And they want it to the, let's see, hundredth place. So that's negative 6.65. So A equals negative 0.65. Okay. All right, an approximate model in intercept form is f of x equals negative. You don't have to put the 0.65 times x minus 7 or x minus 1.7 and x minus 9.2. Okay. Now we're going to graph this to verify that this is that graph. Okay. So now we're going to go to Desmos, and if I delete the scientific portion, go to graphing calculator, y equals negative 0.65 parentheses x minus 1.7 parentheses x minus 9.2. You can see that this graph matches this graph. So let's move on to the next question. All right, question 4, part 1. Find an approximate quadratic model for the data by estimating the x-intercepts and one other point. Then sketch a graph of the model. Okay? Now, you first want to find the x-axis, which you want to find 0. So there's 0 for the y value. that means this is the x-axis. And that is where you're going to find the x-intercepts. Okay, so we draw a curve from the points. Okay, so we have 1.4 and 8.4. Okay, so the x-intercepts of the graph of the model are 1.4 and 8.4. All right, use the intercept estimate 1.4 and 8.4 from part 1 and the point 4, -5 to find a quadratic function model. Round your answer to the, we're going to use capital A to the nearest hundredths. Okay, step 1, find the approximate quadratic function model using the x-intercepts. X1 is 1.4 and x2 is 8.4. The function y equals a, parentheses x minus x1 and x minus x2, and the point 4, -5, which is x, y. Okay, so we're going to plug these values into here. So y is -5 equals a, we don't know, parentheses x, which is 4 minus 1.4, parentheses 4 minus 8.4. Okay, go and finish it up, and we'll move on to the next step. All right. All right, step 2, solve for a using -5 equals a, parentheses 4 minus 1.4 times 4 minus 8.4. We can use Desmos calculator. Oh, we need to delete the calculator portion, I guess. Go to scientific calculator, that's what we want. All right, so parentheses 4 minus 1.4, parentheses 4 minus 8.4 is -11.44. So -5 equals a times -11.44. Okay, so now we're going to divide -11.44 by both sides. Okay, and again we can use Desmos calculator. So -5 divided by -11.44. We're rounding to the nearest hundred, so that's -4.4. Oh, I'm sorry, positive 0.44. So A equals 0.44. Okay. All right, so an approximate model in intercept form is f of x equals 0.44 times x minus 1.4 times x minus 8.4. All right, let's move on to the next question. All right, let's go ahead and graph this and verify that this matches that graph. So, tools, graphing calculator, y equals 0.44 parentheses x minus 1.4 parentheses x minus 8.4. You can see that this graph matches that graph. So let's move on to the next question. All right, question 5. From the graph below, an approximate quadratic function model for the graph data was estimated using the vertex and one other point. The approximate model is y equals 0.20x parentheses x minus 4 squared plus 0.75. Okay. Now, it says in step 1, use the quadratic regression feature on the graphing calculator to find another quadratic function model for the data round to the nearest hundred. So we're going to use this table and the steps from our notes and examples to get the equation. Okay. So what we're going to need to do is go to Google. And we're going to type in Desmos Quadratic Regression. Okay. And remember, we need to delete these values. Okay. And so then it's 2, 3, 5, 7, 8, 9, 2, 1, 1, 2, 4, 7. Okay, and if you press the home key, It adjusts so you can see the points. Okay. Now we're going to find our A, B, C value, plug them into this equation, and we'll have our equation. So let's write those down. So A equals, and we're rounding to the hundredths place, so that's 0.30. B equals negative 2.60, and C equals 6.14. Okay, so now our equation is y equals ax squared plus bx plus c. Now that you have the a, b, and c value, we can plug those points in. So y equals a, which is 0.30x squared. It says plus, but that's minus, so minus 2.60x plus 6.14. Okay? All right, let's move on to the next step. Okay? Step 2. Now compare the two graphs and draw a conclusion. As x gets larger, the vertical distance between the curves for a given x value seems to increase. Okay? Question 6. Part 1. The graphs show the data from the table along with the approximate quadratic model found by estimating the x-intercepts f of x equals 0.40, parentheses x minus 1.2 times x minus 8.5. Use the quadratic regression feature on the graphing calculator to find another quadratic function model for the data. Okay, so it says step 1, a quadratic regression model round to 2 decimal places is f of x equals. So we're going to use this data and the quadratic regression we have here. So what you can do is just delete these values. Be careful not to delete x1 and y1. Now these are 1, x's are 1, 2, 3, 4, 6, 7, 8, 9. And then these are 1, negative 2, negative 3, negative 5, negative 4, negative 4, negative 2, and 3. Okay, so we see our points in the regression. Now we come down here and we need to get our A, B, and C value. So A equals 0.46, B equals negative 4.45, and C equals 5.31. Okay? So our regression, remember, is y equals ax squared plus bx plus c. So f of x equals 0.46x squared minus 4.45x plus 5.31. Okay? All right, step 2. Now compare the two graphs. The regression curve is solid and the original curve is dashed. The vertices of the graphs of the models are almost the same, but the graphs of the regression model is a little narrower. So the greater the horizontal distance from the axis of symmetry, the more the graph of the regression model lies above the graph of the intercept model. All right? Let's look at the next question. All right, question 7. Okay, part 1. Consider the following data set. Use a graphing calculator, and I keep saying graphing calculator, but we're going to use Desmos to create a scatter plot. Then find a quadratic regression model for the data. Enter the quadratic regression model round to the nearest 100. So again, we're going to go to Desmos. So we're going to delete these values. Notice when I delete that, the A, B, and C value go away. So now let's plug those in. So then that's 10, 8, 13, 9, 11, 14, 6, 4, 12, 7, 5. Okay. All right, and then 9.08, 8.34, 8.69, 9, 8.75, 9.17, 8.2, 6.23, 3.15, 9.24, 7.31, 4.72. Okay. See here, regression, but that's not as relevant as this right here. That's what you need. Okay, you need your A, B, and C value. Okay, so A equals negative 0.13, B equals 2.76, and C equals negative 5.86. Okay, so our equation is f of x equals negative 0.13 x squared plus 2.76x minus 5.86. Okay. Now the graph of the regression model is shown below. Trace along the model from part 2 to the nearest tenth. What does the model predict for the rightmost x-intercept? The model predicts 19.5 for the rightmost x-intercept. Okay, and you can find that by coming into Desmos, clicking right there. Okay. All right. Let's look at question number 8. All right. Question 8. The yearly average low temperatures in Fairview is 60 degrees Fahrenheit. The ordered pairs M, D give the month M counting October as M equals 1 and November as M equals 2, and so on. And the number of degrees D Fahrenheit by which the average low temperature for the months October through April departs from the yearly average low. Okay, what we need to do is we need to take these points and plug them into the table. So this is 1, 1, 2, negative 8, 3, negative 15, 4, negative 16, 5, negative 14, 6, negative 6, and 7, 0. Now remember, M equals 1 is October, so this is October, November, December, January, February, March, April. Okay? All right? So for example, in January, M equals 4, the average low temperature is negative 17 degrees below the yearly average, or 60 degrees Fahrenheit, negative 17 Fahrenheit equals 43 degrees. The graph of the data is shown below. Okay? Now, use the quadratic regression feature on the graphing calculator to find an approximate quadratic function model for the graph data. Round to the nearest tenth. An approximate model D equals. So we're going to use this data for the regression. So we're going to come over here. Okay, so then that's 1, 2, 3, 4, 5, 6, 7. And then 1, negative 8, negative 15, negative 16, negative 14, negative 6, 0. Okay, now that shows the regression points, but this is what's important. We need the A, B, and C values. So we see the negative 14.8. So A equals 1.86. Oh, wait a second. Be careful. It said to the nearest 10. So the 6 actually rounds the 8 up to a 9. So that's negative 1.9. Okay. B equals negative 14.8. And C equals 13.7. Okay, so they already gave you the B value and the C value. Okay, oops, sorry, that's a negative 13.7. Okay, and so the A value is 1.9. Okay, now the regression model is shown graphed with the data below. Now, when you graph this in Desmos, you can't use M, so you have to use X. So, go to desmos.com. And we don't use D either, we use Y and X. So, we can type in 1.9x squared minus 14.8 minus 13.7. Let's see that. Wait. Oh, forgot an X right there. There we go. Now, when you zoom out here, and let me make sure we have the value right there. Yep. So you can see that that graph matches the graph on the calculator or on the paper, and we are good. All right, so if you would finish up the assignment and have a wonderful Wildcat day.